This is Math Studies, Lesson 4.1. This is our introduction to coordinate geometry, and this lesson we're going to be talking about distance. So the coordinate plane is what we call what we think about the x and y axis. The x-axis runs horizontally, and the y-axis runs vertically. The quadrant to the right of the y-axis and above the x-axis, we call that the first quadrant. And then we go counterclockwise around the origin. This would be the second quadrant, the third quadrant, and the fourth quadrant. The center of the coordinate plane where x and y meet, we call that the origin. So the coordinates are 0, 0. As you move to the right, the x-axis has positive numbers, and as we move up, the y-axis has positive numbers. So all of the coordinates in the first quadrant will be a positive number, comma, positive number. And then as we move to the left, the x coordinates are negative, so the first value in the ordered pair is negative, but that's moving up for the second quadrant, so those are positive. And if I just keep kind of going around the plane to the right and down will be positive, negative. So whatever number's first, that's the x number, that's how far left and right you go. Whatever number's second, that's the vertical number, up and down. Positives for right and up, and then negatives for left or down. The Pythagorean theorem says that in a right triangle, the lengths of the two legs squared and added together will equal the square of the hypotenuse. So a right triangle looks like that. We have A, B, C, A and B for the legs, and C for the hypotenuse. The distance formula is a derivative of that. If we take x2, I'm going to say x2 minus x1 squared, that's kind of like the length of this base of the triangle, and then y2 minus y1, that's like the length of the height of the triangle. We're going to square them, add them together, and square root them. That's really the Pythagorean theorem, but in coordinate plane form. So those are the formulas that we're going to be using to calculate distance on the coordinate plane. I'm going to scroll down and do the examples then. The first example says give the coordinates of the points. So point A is over in the first quadrant. That is 1, 2, 3, 4 units over and 2 units up. So in parentheses 4, comma 2. 4 to the right and 2 up. B is right here. That is right on the y-axis, so it's actually 0 units over. And then 1, 2 units up. Letter C is in the second quadrant. That is 1, 2, 3 units to the left. We represent units to the left with a negative, and then 1 unit up. Coordinate D is right here. That is 1 unit to the left and 0 units up. Coordinate E is right here. That is 1 unit to the right and 2 units down. So all of my numbers that went to the right were a positive number in the first piece of the ordered pair. To the left were negatives, and then anything going up was positive in the second coordinate, and down would be a negative. Okay. Example B says use the Pythagorean theorem to find the distance between the points. So here is point A, and here is point B. I will add a vertical and a horizontal leg to turn this into a right triangle, and now I can use the Pythagorean theorem to find the distance there. The vertical distance here is 2 units. The horizontal distance here is 3 units. Those become the legs of my right triangle. So I wrote this above. We're going to do 2 squared plus 3 squared, and that is 4 and 9, which is 13. So if c squared is 13, c would be the square root of 13. So I will use my calculator to get a decimal. The square root of 13 is approximately 3.6. So this distance here is approximately 3.6 units. And my final example says use the distance formula to find the distance between points -2, 1 and 3, 4. So the first thing I'm going to do is label these points. My first ordered pair, -2, 1, the first coordinate is the x-coordinate, and the second number is the y-coordinate. Since this is my first point, I'm going to label them y1 and x1. My second one, again, x, y for ordered pairs. The second point, so I'll put 2's on both of those. And then those are the values that I'm going to put in the formula that I wrote way on top. So that is, in parentheses, x2 minus x1. Notice that's minus a -2. We can switch that to a plus if we wanted to be a little simpler. Squared plus, and then in parentheses, y2 minus y1 squared. Square root the entire expression. Depending on what tool you're using to do this, if you have a graphing calculator or even a scientific calculator that knows how to do order of operations, you could type this entire expression in. You just need to be careful. Most of the TI calculators, there is an automatic parentheses when you do a square root. That is not the same as the parentheses by the 3, because that parentheses is showing you where the square root starts and ends. So you would need to do a double set of parentheses there. If you're just going to use PEMDAS, you're going to do it by hand, you don't really need to worry about the parentheses so much. But if I was going to do this by hand, 3 minus -2 is the same as 3 plus 2, so that's 5. And 5 squared is 25. 4 minus 1 is 3, and 3 squared is 9. So 25 and 9, that's 34. And if I square root 34, that should give me the answer that I'm looking for. And that is 5.8 approximately. Okay, that is it for the notes for lesson 4.1. Good luck on the exercises, and please let me know if you have questions.